we are actually going to be learning 3 different methods of graphing lines. So we already did the first one, which is a table of values, and we're going to look at the intercept method. So let's see, table of values. That was where you make a little XY table. You put in some values of your domain here, feed that X through the rule, come out with some Y values, you get some XY pairs, we graph them, right? So that was this. Now connect the points. Well, we do that based on domain. So depending on what your domain is, you may connect the points, you may not. When don't you connect the points? When don't you connect points? Oh, just 2 people. More than when don't we connect points? Connor, when don't we connect points? When it's not all real numbers? Anytime it's not all real numbers? What specific case do we not connect points? I'm going to ask Ryan then.
When a specific set of data.
Yes, so do you have a domain that looks like this? How many points will show up on my graph?
3.
3, right? And you'll just see 3 dots somehow, right? If my domain is something like this, what might it look like? Do I connect dots now?
With array.
And then like if this is where 0 is, something like that. And if my domain is all real numbers, then that's my double arrow because I want to include all possible x's. So I hope that's a little bit clearer than when we started. So now we're going to look at our second method, which is using intercepts. Oh, let's see. Now let's think about this. I'm saying a big statement here. We know. I don't know if we do or not. How many points do you need? The minimum number of points do you need to create a line? Minimum number.
1.
1? Can I make a line with 1 point? Yeah, I could. I can make this line. But I could also make that line. And I can make that line. How many lines can I make if I only have 1 point? Infinite number, right? More than 1 million. I can make an infinite number. So if I want to make a specific line, what's the minimum I need?
2.
I need more than 1, right? Because 1 gives me an infinite number. But if I have 2, can I make any other line than that one? No. So I really only need 2. So when you're doing this method, we would come up with a whole sample of them. How many domain members did I really need? I really only need 2. And I can start seeing what the line looks like. So I'm going to use this fact that I'm going to pick easy points to find. You like easy? Yeah. Of course we like easy. So let's review what x-intercepts and y-intercepts are. Without looking at your notes here, because I think you know this. What is an x-intercept? What is it? What is it? It's something with the x-axis, yeah? Yeah?
When a plot is on the x-axis.
When a point is on there, right? An x-intercept is when you graph a relation, or not even a point, graph anything, right? Graph a relation. The point where a graph crosses the x-axis, okay? It's where the graph crosses the x-axis. Here is my x-intercept for this particular it's the function that I'm looking at. There are other cases where it crosses. I like to put the word touches here as well. There are other kinds of graphs that bounce back. So here's also an x-intercept. It's any point on a graph that touches it in any way, crosses or touches it. Yeah. It's hard for you to go? Okay, hang on 1 second. All right, now what's a y-intercept? It's the point where a graph crosses the what? The y-axis. So this is a y-intercept. Okay, so here's the tricky bit. It's not even that tricky. If you were to write the xy pair for any x-intercept, so here's this one, it's 3, 0. What if I had another one, a line, and it hits here? What's the x-intercept? 1, 0. What if it crossed here? What if it crossed in between there? 2 point something, right? Comma 0. What is the y value of any x-intercept? 0. Yeah or no? 0. And this is an important thing, and for some reason, we have trouble with this. So I want you to kind of find that on the paper there, where it says finding intercepts near the top. Circle it. This is kind of an important thing, stars. Because some people have trouble with this. Maybe this same picture is on your paper, so maybe you have an arrow. X-intercepts always have y equal to 0. Maybe point to your graph there. Now what about y-intercepts, right? That's where I cross the y-axis, cross or touch. So this point is 0, 6. What if it was sitting here? What would that point be? 0, maybe that's a 4, I don't know what it is. What if it was sitting here? I don't know exactly maybe what the y value is, but what is the x value always for a y-intercept? 0. Right, this is important. So x-intercepts always look like this, and y-intercepts always look like that. X, 0. Whatever x is, I don't know, but I know its y value is 0. And for a y-intercept, the x value is always 0. Y can be whatever it is. Do we get that?
Oh.
Thumbs up, middle down. I just want to make sure, because it's easy, but then we kind of, I don't know, we kind of lose it. Everybody, I need to see thumbs up, middle down. Now, if we're a middle or a down, ask me a question now. I'm trying to see where we're getting lost. We have a few middles. You never say, no, I thought up. No, why? Where's the question? Where am I losing you? Just think everywhere. What? Here's a point. What is the y value of this point? Y value. Y is when how far am I going up?
0.
So I don't know what x is, but I know what that is. What about this one? What's its y value? 0. I'm not going up or down, right? Now what about going along the y-axis?
3.
0 something, right? I don't know what the y value, I know it's 0. That's my whole point here. If you're on the y-axis, the first coordinate is 0. If you're on the x-axis, the last coordinate is 0. Okay, so we're going to name the coordinates of these xy pairs. What's the coordinate of the x-intercept? What's the coordinate pair, the xy pair? Connor, what do you think?
I think it is 0, 2.
So 0, 2 is up here. Is that an x-intercept? This is x, and this is y. So what's the x-intercept? Try again. -2, 0. Notice how y value is always 0 for an x-intercept. Let's find the coordinates of the y-intercept. Ryan, what's the coordinates? Ryan, M? 0, 2. Now this one is the y-intercept. Puts me up here. X value is 0. Okay? So that's the tricky bit. An x-intercept has a y value of 0, and a y-intercept has an x value of 0. And there's my words again, leave it up, sister, just to remind you. Yes?
I got it.
And what you do is if you forget this, draw a picture and say, wait a second, which is 0, the x or the y? Right, this is an x-intercept, right? Which is 0, the x or the y? Y equals 0. Here's a y-intercept. Which is 0, the x or the y? Draw that little picture to remind you if you forget. It's better than memorizing, right? So to find the x and y intercepts of graphs, I take whatever the function rule is, and if I want an x-intercept, set y equals 0. I know what half the coordinates is, solve for x. If I want to find a y-intercept, I know half the coordinate already. Starts with a 0, plug a 0 in for x. Okay, now you can make a little table to help you do this. Let me make a little table. What do I mean by that? XY table. Make one with an x of 0, make one with the y of 0, and plug in accordingly. So we're gonna practice that. So finding x and y intercepts here. Let's see what the example is. I've got 2x plus 7y equals 28. Middle of page 1 there, right? You see that example? If I want to find the x-intercepts, now the notes are on your page, which means you can look up. So to find the x-intercept, this is generally what it looks like, right? X comma 0. Because what's the y value here? 0. So I'm going to set y equal to 0. What am I talking about? Here's the rule. So set y equal to 0 because I know half the coordinate already. Well, the y is 0. That's it. So 2x plus 7 times 0 equals 28. Well, what is 7 times 0? 0. So 2x equals 28. So what's x? 14. So what's my x-intercept? 14 times 0. Alright, now let's find the y-intercept. I'll put that here. Now a y-intercept, that's something like this, right? Is the x 0 or is the y 0?
The x is 0.
So I'm going to set x equal to 0. Same thing, because it's the same function that I'm using. This time, this gets set to 0. Well, 2 times 0 is 0. So what's y? 4. So what's the xy pair for the y-intercept? What's x? Yeah, Matthew, what is it? 0, comma 4. Who followed that?
I did.
Now who was like, what? Anybody? She did what? Remember how this works. This is a series of x and y's that make this equation true. Now when we looked for solutions the other day, one of the things we did was we said, how do you know? And one way to do that is say, well, why don't you just plug in an x and solve it for y? Remember? We can find xy pairs. It's kind of what we're doing, except first I'm going to put a 0 in and find the y value. That's my y-intercept. Then I'm going to put a 0 in here. You with me? Then I'm going to put a 0 in here and then solve for x to get my x-intercept. And then, so what? What do we do with these things? And I just put a little reminder here. We said y equals to 0 to find x-intercept and x equals 0 to find y-intercept. For finding an x-intercept, you should end with x equals. When you're finding a y-intercept, you should end with y equals. Right? Okay. Or you can make this table if that's easier to see. So 2x plus 7y, this is like the table we did with table of values. Make the y 0, make the x 0. And it's going to tell you what to do there. So put a 0 here. You're still going to get the 14. When you do this one, you put the 0 here, you're still going to get the 4. You're going to do the exact same thing we did before. So I can see my 14 0. I can see my 0 4. And I've got my 2 intercepts. Yes? I only plug them in one at a time. Oh, what an excellent point. Only plug them in. So I always write a little note here. Now I'm working on the x-intercept, which means y equals 0. So 2x plus 7 times 0, which is 0, equals 28. So x equals 14. Don't plug the 0 into both at the same time. Right? You can only do that if 0, 0 is a point on the graph, which is this one. 2x plus 0 equals 28. Right? I'm plugging it into this. Right? Just like you do with the table of values. And this is the coordinate I'm trying to find. I already know that the y is 0, so I'm finding the x. Yes, sir?
Can we ever have to back to the equation?
Yeah, that's the whole point here. So now, yes, thank you. Leading me into what do you do with this? I think I got a slide for that. No, not yet. Let me just show you what you're going to do. I have 2 points. I have 14, 0, and I've got 0, 4. Connect them. Yet if the domain is all real numbers, I'm done. So the idea is, it's like table of values, except you're finding 2 points, and 2 points that are relatively easy to find. Working with 0 is always easy. What?
So we're going to do this method.
Yeah. This is a good method. This is not punishment.
So
This is actually, I think, in many cases, easier than the last one.
I'm confused on intercepts.
Let's do it again.
That
Okay?
sounds like you're
Let's do it again. What? It sounds like I'm what?
you're adding 0 to both.
I'm not adding 0. What I'm doing is I'm finding the xy pair that looks like this, and the xy pair that looks like this. Because x-intercepts have a y value of 0, and y-intercepts have an x value of 0. So that's what I'm trying to find. You can use the table, you cannot use the table, but that's what I'm trying to find. But how does the table work? The table says plug this in for y. Okay, so let's do that one. We're going to put it down here. So 3x plus 2y, well I think y is 0, or I'm making y 0, equals 6. 3x equals 6, x equals 2. X equals 2. Is this an x-intercept or a y-intercept? It's an x-intercept because it looks like this. Right? Now the y-intercept occurs when the x is 0. So let's do that one. That's this one up here. So So when does x equal 0? When 3 times 0 plus 2y equals 6. That's 0, right? So when does 2y equal 6? When y equals 3. So what point is this? 0, 3. The y-intercept. Now what would you do with this? You would say, well, let's see, 2, 0, I guess is over here somewhere. 0, 3 is over here. If you're using a domain of all real numbers, there it is. Just graphing those 2 points. Why is this hard? What's hard?
Nothing's hard on it.
Something's hard because you guys look like what?
We're just tired.
Stop being tired. No, wake it up.
It's on Monday.
No, that's you should be rested. All right, now look at this one. X-intercepts look like this. The y equals 0. That's this one. So you take this little function and you set the y equals 0. Well, 2 times 0 is 0. It's gone. 4x equals 10. 2.5. Nope, watch this. Divide by 4. You don't need calculator at all. X is 10/4. Is that in simplest form? No, I can divide both by 2. 5 halves. Here it is. 5 halves. See? That's all you gotta do. I don't need a calculator. 5 halves. And then y-ins are when they look like this. 0, y. That's a y-intercept. X is 0. So 4 times 0 minus 2y equals 10. Well, 4 times 0 is 0, so it's just 2y equals 10. Divide both of these by -2, and y equals -5. 0, -5. So that is 2.5. Just leave it a fraction. I want you to get out of automatically turning everything into a decimal, okay? 5 halves is fine. So leave it like that. What's 2.5? If you had graphed it, you know how to graph that, right? 5 is 2.5. Alright, so now what about this one? So number 3, what are we going to do here? Somebody else, somebody who's like, I really am confused. Looking for you. Really confused. Claire, how do I find the x-intercept? What do I know about x-intercept? What does it generally look like? Yeah. So what am I going to substitute in for 0 here? Yep. So I take -3x plus 5y. Y is going to be 0 for that point. Yeah, 15. That's what it says. So what's x? Divide both sides by -3. 5. Because y. Negative over negative is positive. 15 over 3. So that goes here. What's your x-intercept? 5, 0. Okay, now what about the y-intercept? Who was somebody else who was like, what? Ben. So what is the general format for a y-intercept? What does that look like? What? It's 0y, right? So what am I going to substitute for 0 here? The x or the y? The x. So let's do that down here. It's -3 times 0 plus 5y equals -15. What's -3 times 0? 0. So what's y? -3. So what are the coordinates of my y-intercept? These are the 2 things you graph. And that's it. That's the intercept method. It's all you have to do. Questions? No? Okay. So graphing them, like we've already talked about it, but we're just going to just graph them. So 14, 0 doesn't fit. I'm going to count by 2s. 2, 4, 6, 8, 10, 12, 14. Some back here. And then 0, 4, I'm still counting by 2, so that goes here. Connect them. We have it. This is if domain is all real numbers. It doesn't say, so assume that the domain is all real numbers, just like we did before. What you got to do, that's it, that's it. Right? Step 1, find the intercept, right? That's on your paper? Yep. Well, we did it already, right? That's what we did over here. This is what you're doing now. So it's going to be 14, 0, and 0, 4. Why? Because you're going to plug a 0 in here to get the x-intercept. To find the y-intercept, you plug a 0 in here. That's it. Easy. I hope so. I mean, I hope we can do a couple of other easy. So I have another example here, which I don't think is another paper. It's not. All right, so let's just look up here.
That is.
It is? Oh, there it is. Okay. So we're going to graph this. using the intercept methods. So to find the x-intercept, what gets set to 0? The y. So I take x plus 2y, and for y I'm going to substitute 0. What's 2 times 0? 0. So x equals, oh, that was an easy one. So what is the x-intercept? It's 4 times 0. Now let's look at the y-intercept. Those have the pattern 0, y, right? So what gets plugged in here? Matt, what do I do here?
You plug in 0 for x. So that must not really go 2y equals 4.
So it's y. Okay, y goes side by 2, that goes here. So what's my y-intercept? 0, 2. Now let's plot these points. I've got 4, 0. 1, 2, 3, 4. And then I've got 0, 2. Connect these guys. The domain is all real numbers unless it says otherwise. So I'm going to go ahead and put those together. Done. Okay, what do you think? That's it. That really is all there is to it. Now you could possibly, I can't think about an example here or not. These are U-tries. I just want to talk about one other thing, and then we'll go back to U-tries. I want to bring up some new vocabulary called the zero of a function. It's easy though. The zero of a function, when we talk about a value of a function, what's the function at this x value? We're talking about what is its y value. So when I say, what's a value of a function at 0, what is the value of a function at 0? What do I mean? I want to know when y equals 0. I want to know when the function itself is 0. When the y value of a function is 0, we say it's at 0. But also, when else do I make y equal 0? Go back here. When did I make y 0? For these. When does y get, if you make y 0, what do you get? An x-intercept or a y-intercept?
X-intercept.
X-intercept. So what's another name for a 0 of a function? An x-intercept. So you're going to see this word a lot. Zeros of a function. What's the zero of the function? I'm asking you to find an x-intercept. I'm asking you to set y equal to 0. Okay? So, for example, if I have a function, I'm trying to make it hit. What's the 0 of this particular function? Well, that's the x-intercept. The 0 is -1, -2, -3, -4. Is the 0 of this function right here. Okay, what if things we haven't even looked at? What if I have something like this? Oh, it's trying really hard to do. We haven't even looked at anything like this. Where are the zeros of this function? Where are they? It's hard to tell, right? Zeros of a function are x-intercepts. We're going to repeat that. I'm just saying you're going to repeat it. Zeros of a function are x-intercepts.
Zeros of a function are x-intercepts.
Everybody can say, we'll do it again. Zeros of a function, wait, I'm going to say it, you're going to repeat it. Zeros of a function are x-intercepts. Everybody.
Zeros of a function are x-intercepts.
Awesome. All right, go ahead and do tries. Do you tries? When you think you have them, the zeros are, not the zeros. The results are up there. The x-intercept, y-intercepts. Check your answers when you're done. Make sure you're doing this right, okay?
I didn't make the chart.
You don't have to use the chart if you don't want to. You can just say x-intercept occurs when y equals 0, right? I want to have an x0. I don't personally use the chart. It's there to make it easier, I hope. So -4x plus 3 times 0 equals 24. -4x equals 24. That means x is -6. So here I'm at -6 times 0.
We have to work all this out as this here.
Well, if you're kind of seeing a pattern here, when you're in this standard form, these are a lot easier. It's like these kind of disappear. What's the y-intercept? When 3y equals 24, right? Y equals 8. But I want you to kind of write this stuff out at first until you kind of see why that is. Only when you're in standard form, though.
Sorry, but